CNT120, Chapter 3. We have one more segment here on IP version 4. We have some special addresses to be aware of. We left off on basically in this slide here, reminding us about the network number and the broadcast number for IP version 4. Whenever the host portion is all zeros, that is the network number identifying the network. Whenever we have all ones or all ones are 255 in the host octet, that's a broadcast address. That's a message that goes to everybody on that network. That's kind of where we left off. There's a couple other numbers we want to be aware of. 0000 is currently not assigned, not used for anything. 255, 255, 255, 255 is a broadcast message for all nodes on all network, the whole network. Again, you don't assign that to anything. That's just something that gets used. 127.0.0.1 we mentioned previously, that's our loopback address. That's our loopback address. So go right here. Our loopback address 127.0.0.1, if I were to ping that, let's do a clear screen here. If I do a ping 127.0.0.1, again, that's kind of like leaning outside my door and ringing my own doorbell and checking, maybe I just installed a new doorbell. I lean out my door and I push the button to see if it works. That's what this is doing. When I ping 127.0.0.1, I'm literally kind of like pinging my own NIC, if you will, seeing, is the NIC functioning? Is TCP/IP installed? Is it recognizing all that? And if I get successful replies, it's letting me know all that is indeed functioning. So that is set aside for that purpose. That 127.0.0.1 is set aside for that particular purpose. We mentioned before the APIPA addressing, automatically privately assigned IP addressing. If a computer is set for DHCP to receive an address dynamically, and it is not able to communicate with the DHCP server, cable unplugged, problem in the network, server shut off, etc., the workstation tries a couple times, and if it doesn't get it, it's like, oh well, kind of shrugs its shoulders, and it self-assigns. It gives itself an address in the 169.254 range. Well, for us as network technicians or IT people, typically we're going to have IP addressing set for dynamically, and typically workstations should be getting addresses from the DHCP server. So if we happen to sit down and see, and I think I have here an example, the client is trying to contact the DHCP server and it is not able to for some reason. Cable disconnected, switch port is off, server is off, server cable has a problem, etc. It's going to self-assign a 169.254. So if I'm set for dynamic, obtain an IP address automatically, and I can't get it, it self-assigns this 169.254. Well, if I go to check the IP addressing on a machine and I see 169.254, I know I need to start troubleshooting, because I normally never ever want to see this. I can't think of a time I actually want to see this number. Because this is not a routable number. I'm not going to get through my network and out to the internet. So it is time where I need to start troubleshooting. That's what that usually means for us as IT people. So 169.254 is the automatic private IP addressing. Keep that in mind. The 169.254 is like a little red flag that pops up on my head of like, okay, start checking connections, start checking settings. Something is not right. Other things we need to be aware of are literally private addressing. Class A, B, and C licensed addresses are available for use on the internet. These are called public IP addresses. Well, since we ran out of IP version 4 addressing a number of years ago, private addressing got created as a way to allow devices on my network to connect, and I can translate that into a public IP outside. So as I take a peek here, and I think I have, actually here we go. Here's the ranges of numbers that can be used. I can decide to use these on my network if I want to, and then I translate them to the public IP addresses outside. There is a 10 network, there's a 172 network, and there's a 192 network that can be used for private addressing. Those probably look familiar because usually our devices at home, our routers at home are actually configured with a DHCP server to hand out addresses usually in these ranges. That's done on purpose. That is done on purpose. So here you go. 10, 172.16, and 192.168. These are all typically the addresses that are used, again, like in your home networks. Here's the subnet mask for the 10. It's a Class A. Here's the subnet mask for the 172. It's actually like an A.5. That's kind of what's going on there. And the 192.168 is kind of a B. That's essentially like a B network. So these are kind of special, and you kind of handle them specially. That's why I'm putting here the IP range and then the subnet mask. I need to be aware this 10 is an A, this 172 is something like an A.5, if you will, and then the 192.168 is essentially a B, giving me lots of addresses to use on my private network. Well, how this works is my private addressing scheme inside my network is going to get translated by my router to a public IP address outside to connect out to, my provider network and or the internet. So this network address translation gets done to do this for me. So here's my private network running a 10. My my devices connect to my gateway to my router. My router then is programmed to translate these 10 addresses over to the public address of 9254. This is configured to translate them so that all of these devices here can connect out to the internet with this public IP address. This is what your router at home does. This is what routers at most businesses do. This is just what they do now. And that's because a number of years ago we ran out of IPv4 addresses. This is one way to meet this need. Because again, real quickly, at your house, Comcast, Verizon, whatever you're using, you literally have one IP address allocated to your house. That's what they've given you. And your router at home, remember it's a network in a box, but your router at home translates that single IP address into one of these ranges of private IP addresses that we talked about. A lot of times it's the 192. And that theoretically allows you to connect 65,000 devices in your house to your network and out to the internet. That's kind of silly, but it's giving you the option that I can have 10 or 12 devices in my house connect through this gateway router and get out to the public network of Verizon, Comcast, whoever it is. And that is through network address translation. Now, how it's actually doing that, and right here is a definition, port address translation. What it's doing is all of these addresses inside are getting translated to a single IP address outside. And it keeps these separate by using a different port number for each computer. So each of the computers in here get translated into a table to this public IP, but then it uses a different port number for each one to keep their traffic separate. So port 2000 for this computer, port 2001 for this computer, port 1002 for this computer, and so forth. That way it can keep their traffic separate as it gets returned from the internet. That's port address translation. A lot of our networks at home use that. There is also variations or static network address translation, dynamic network address translation. Here's some examples of static, given the same IP address inside outside, as well as dynamic. These tend to get used when I'm trying to hit a specific entity on the inside. Up here, it's a little tougher to have traffic from the internet hit a specific entity. So I move into this static round, or that allows you to have a device like a server in here that I can get to from the outside. There's a mapping to that. Most of our networks and most of what we deal with at this level is this right here, this port address translation. That's really what your network at home is running as well. Alrighty, we will come back in the next section on IPv6 addresses.